So we want to find the recursive rule for this sequence. So these tend to be a little bit easier. So let's see. I need to basically say, okay, how do I get from this one to this one, or from this one to this one? So like, it looks like I'm just taking this times 2, then times 2, then times 2. So I would say a sub n is equal to a sub n minus 1, 2 times 2, right? We also need to state what a sub 1 is. A sub 1 is 1. I guess in all of these, a sub 1 is 1. A sub 1 is 1. All right. So since we're doubling each time, we can say it's 2 times a sub n minus 1. This one times 2 times 2 to So what did I do to this? So this time I'm adding 1, this time I'm adding 2, this time I'm adding 3. So we could say a sub n so I want to figure out a way that only references the previous thing, because I'm like, well, we could say something like a sub n minus 1 plus, let's see, that's 1, that's 2, that's 3, plus n minus 1, like the actual, like, make just plus the coefficient n minus 1. But I feel like that's cheating. I feel like we're not allowed to write that. This was supposed to be like normal sized. So I'll need to cheat and look that up. Then this one, plus 1 plus 2 plus 6. Nope. So I wonder if we can, is there a factorial hiding in this? 1 factorial, 2 factorial, no. Let's see. All right, well, I'll give these away in class. I thought recursive was going to be easier. In this case, it's harder for me. All right, well, oh, these are in an inconvenient order. Let's see. So there's divergent and convergent. Those are buddies. And then monotonic is like its own thing. And then bounded and unbounded are related. Okay, so a convergent sequence is one that goes off, as we go off, like as n goes off to infinity, it approaches a number. Divergent does not approach a number. So this very first one that we looked at today, which was like hopping between 3 and 5, that's not convergent. That would be considered divergent. It is, however, considered to be bounded because it's bounded on either side. It doesn't fly off to infinity in either direction. It's only 3 and 5 and 3 and 5 and 3 and 5 and 3 and 5. And it is not monotonic. And we'll talk about monotonic more, but monotonic is essentially either it stays the same or it increases, or it stays the same or it decreases. So let's see. This next one, we want to look at these terms. Oh, and I don't have this is a new version of the file, so I have to refind these. So it's 3 over 2, and then 6 over 3, which is 2, and then 3 3 is 9, 9 over 4. And so we want to talk about, is this convergent or divergent? And if you remember, like, just think about, does this have an asymptote? You know, horizontal asymptote as we go out to infinity, or does it have a limit as we go out to infinity? Yeah, its limit is 3. So this converges. We don't care what it converges to, we just care that it converges. But it does converge to 3, the terms do. This is it always increasing? Like, is it strictly either increasing or flat? Let me just double check the next one would be 4, so it'd be 12 over 5. Yeah, it looks like it's going to be continually increasing, so we could call this monotonic. Something that wouldn't be monotonic would be this first one, where it's bouncing back and forth, up and down, and up and down, and up and down. Monotonic is like up, maybe it's flat for a little bit, but then it's continually going up after that. Flat, up, flat, up. Monotonic, it's convergent, it's monotonic, and is it bounded? So that means, like, is there a ceiling to this? And yes, the ceiling is 3, so it's bounded. All right, this one, all right, got to regenerate the form again. Oh, so looks like the first one's 0, right? Oh, this is a new one. This is a different example. Because you plug in 1, you get 0 over 1. Plug in 2, you get 3 over 3. Oh, you get 1. Plug in 3, you get 8 over 7. Plug in 4, you get 15 over 15. Plug in 5, you get 24 over 31. Plug in 6, you get 35 over 63. Okay, so let's just figure this out. This is 0, this is 1. This is what, 1 point, is that 1.14-ish? Let me just double check. And 1, then 24 over 31, that's point something. Okay, so this is a great example of something that is not monotonic. 0, 1, 1.14, back down to 1. It was going up, then it came back down for a second. That's not monotonic. Let's see, 2 to the x. So let me just have it generate table values. Tables start at 1, go by 1, just do it for me. All right, so goes up, comes back down, goes down, down. Oh, they're getting smaller and smaller. Oh, okay, so it came up for a little bit, but then it's just going down, 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 down. Okay, so what does this approach as we go off to infinity? This actually approaches 0, right? Because 2 to the n versus n squared. 2 to the n just kills the n squared. So this is all going off to 0. So this actually is convergent, and it's also bounded. Because it doesn't fly up to infinity, it just flies up to 1.14. Yeah, I remember that a 7th is like 0.14-ish. So it's convergent, it's bounded, but it is not monotonic. So let's see, A, we could say it's convergent. We could say it's monotonic because it's going up. And it's bounded by that asymptote there. This one, we can say it's bounded, but it's not monotonic because it comes up and down. And it also converges, right? Because it's converging to 0. Then we got this one. It's monotonic because it's going up. It's not convergent, so we'd say it's divergent. And it's not bounded. Oh, I should have written that different. That's more fun. So it's divergent, it's unbounded, it's monotonic. And then our last one here, ping pong back and forth. So it's not monotonic. It's unbounded, right? Because it's going off to both infinity and maybe even negative infinity, but it's doing something weird. And it is divergent. Since it's going like that, it's likely going to just go more and more and more extreme, like away from each other. So my expectation for you guys is that you will be able to handle the homework questions. I'm trying to think, is there anything? So, yeah, we're just trying to find out if things basically, yeah. No. So there's some where you got to find the actual sequence. A lot of them you got to find out if it's convergent or divergent. And then monotonic, bounded stuff. You don't have to show work. Like with this one, how I knew that it was convergent based on my analysis of this. That's great. So lots of shortcuts you can take. You know, since we're 12 minutes in, just let me, may as well. Go through my files. Oh, good. I don't have the complete book here. What? Where did I put that? Is it in here? There we go. Okay, so solutions. I think we're going to be in here. So let's see, we wanted, oh no, I'm so glad I looked at this. If you were confused about my cosine stuff that I talked about earlier, I thought about this and I forgot to say it again. It's pi over 2 that it's going by. It's not regular pi's. Oh boy, that's annoying that I messed up like that. So then let's see, we got 2 times, oh, that is what they did for B. And then for C, oh, that was tricky. Yeah, so good on you if you figured that out. And if you figured out something else, let me know what it was. I'd love to hear a different explanation that you got. Cool, well, besides the error earlier, I hope this video has been helpful. I think I'm gonna have to cut I need to cut the beginning of this off. It was bad. So over 2 over that's how that yeah. Would this even do it? I think so. Alright, well, I'm gonna cut this part of the video off anyway. So see you guys. Well, not this part, the beginning part. Maybe this part too. I'm gonna cut it right